In the last lectures, we have done the introduction to inductors and resistors. We have also done the series combination of inductors and resistors along with the parallel combinations and how to solve the equivalent circuits containing series and parallel combinations of inductors and resistors. Let us start with the capacitors. Those students who have attended the class in physical mode, they have got the introduction. What are the capacitors? So capacitors are those elements which are having ability to store the electrical energy in the form of electrical field. So by definition, it is known as the property of the capacitor by virtue of which it stores electrical energy is known as capacitance. So what happens is whenever we apply a supply, let us say we have applied a battery to the capacitor with a positive and negative terminal. It will develop positive charge over here and negative charge over here, and it will store energy to its maximum potential. It will store energy to its maximum potential or energy. Is that clear? So the expression of the current within a capacitor, it is given by the formula I is equal to C dV by dt. I is equal to C dV by dt. So this is the formula for the current which is carried in a capacitor. From this particular part only we can also derive the expression for the voltage. So how we can do that? So take capacitance to the left hand side. So here it is I into 1 by C dt is equal to dV. So as we know capacitance is a constant, so we can take it outside and the expression can be I dt is equal to dV. So when we integrate on both the sides, the expression will become V is equal to 1 by C integral of I dt. So we can find the expression for current and expression for voltage of a capacitor by using these formulas. Is that clear better? Yes, sir. Okay, so the unit of capacitance is farads. It is always measured in farad. So farad is okay. So now let us again start with the capacitors. So the unit of capacitor is farad, but farad is a very large capacitor. So if we want to make a capacitor which is having the strength of 1 farad, the size of this would be comparable to that of earth. So capacitors of this size are not available, but with the modern technology we have compressed the size of these kind of capacitors and they are easily available now. But in our daily routine, in our electronic devices, we use capacitors of picofarad and microfarad. Is that clear? Any doubt in that? Yes, sir. Okay, now let us start with series and parallel combination of these capacitors. Series and parallel combination. Now you are having two formulas. Which are these formulas? I is equal to C dV by dt. I is equal to C dV by dt. And from this particular formula, we have also derived the expression for voltage. V is equal to 1 by C. V is equal to 1 by integral I dt. Integral of I dt. Just remember these formulas. Now let us take the example. Consider there are two capacitors and these are connected in series. They are connected to a voltage source. This can be AC or DC. Let us say this is capacitor C1, this is capacitor C2. Now, what will happen? As you all know, in series combination, the current remains same and the voltage gets divided. So the two voltages will be VC1 and VC2. So the voltage gets divided. You can write total voltage is equal to sum of voltage across capacitor C1 and sum of voltage across capacitor C2. Now what is the formula for voltage? 1 by C integral of I dt. For VC1 is the voltage across capacitor C1. So we will write here 1 by C1 integral I dt. I will remain same because the circuit is in series combination, plus similarly 1 by C2 integral of I dt. Again the current through capacitor C2 is also same. Now as you can see, you can take common. What you can take common? This total expression, this can be taken out from the both sides and it will be cancelled out. So 1 by C equivalent series capacitance will be equal to 1 by C1 plus 1 by C2. Is that clear, beta? So the expression can also be written as C equivalent is equal to C1 C2 by C1 plus C2. So in the previous cases for inductors and resistors, this was the expression for parallel combination. In this case, for the capacitors, this is the expression for series combination. You have to remember that. Okay, beta? Now, consider now parallel combination. Consider parallel combination. So let us say capacitor C1 is connected with capacitor C2 in parallel combination. So if they are connected to any voltage source, what will happen? The voltage will remain same and current will get divided. Let us say this is current I. The current in capacitor C1 will be I1 and in capacitor C2 will be I2. So as the current is divided, we will write I is equal to I1 plus I2. Is that clear? So what is I? The expression for I is C dV by dt. So the current I1 is associated with the capacitor C1. So it will be C1 C dV by dt. Why V is same? Because in parallel combination voltage remains same. So similarly this is the combination, this is the expression for current I2. Now what is common? What is common in that? dV by dt is common and can be cancelled. Yes. Now C equivalent will be is equal to C1 plus C2. This is the expression for parallel combination of capacitors. Is that clear, beta? You can take the screenshot of this. Any doubt on that? Okay. So take 2 minutes to revise and so that we can move on to the next topic. So shall we move on? Okay. So okay, our let us discuss the advantages of circuit elements. So what are the advantages of resistors? They can control the flow of current by resisting the current. They can protect other elements from large currents. Whenever there is a circuit, let us say you have connected a bulb to a voltage supply and abruptly the voltage has increased by somehow due to any complication or defects. So what will happen? It will blow out this bulb. Now if you want to protect this bulb, just connect a resistor in series with that particular bulb. It will protect the overflow of current. So in the similar way, it also provides regulation of voltage in the circuits. Regulation means to control the voltage. Now, these are the advantages of capacitors. So, it is used to store and release energy. It is used to store and release energy. How it is performing this action? Let us say you have charged a capacitor with the supply and it is already having positive charge over here and negative charge over here. Now, if you connect it or short it with the resistor, it will release energy. How? In the form of current. Whatever strength it is having, it will release energy in the form of current and current will flow from positive terminal to the negative terminal, and there will be a voltage drop across this particular resistance according to the expression V is equal to IR. Any doubt, beta? No, sir. Okay. No, sir. ठीक. Okay. Now it also provides stability and response time in the circuits that we study it in the later topics that are coming into your CO, which is having a response of AC circuits. In that particular CO, we will study this. Okay. Now the advantages of inductors. You already know it stores energy within a magnetic field. It also serves as a means of cleaning high frequency noise. Means we can use inductors as filters to remove the frequency components, certain frequency components. It's a deep and vast topic. Just remember, if we are having some unwanted signals in a particular communication, electronic communication, we can use combination of inductors and capacitors to remove those frequencies. Okay. So next is it provides reactance when used in AC circuit. What is the reactance? It is the you can say as the resistors offer opposition to the flow of current. The opposition offered by the inductor is known as reactance, or it stores energy in the form of magnetic field. That energy can be utilized in a way which is known as reactance. Is that clear? Is that clear, yes, madam? Sir. Okay. So what are the disadvantages? So whenever current is restricted, the loss is in the form of heat. So heat is produced whenever we connect resistors in series. So maximum current is not achieved. Whenever the current is limited by a resistor, it is obvious that we will not even ever achieve the maximum value of current. So the disadvantages of capacitors is energy storage is limited. It can provide energy, it can provide electric energy, but to a limited extent. It will not provide energy to its full strength. It always requires a backend supply or a supply to maintain its charge, which is stored on its plates. So charge can leak through it. So you might have seen the condensers which are connected in your fan, they'll get weak by the passage of time. So it is due to the leakage of charge. The charge storage stored is leaked whenever the capacitor is not used or it is used for a long period of time. Okay. So inductors are much bulkier and heavier than other components because it is a coil of wire. So more the strength of inductor, more will be the bulkiness of that particular element. So wires can add certain loss. So in along with the inductive reactance or inductive action, it is also having some kind of resistance because each wire is having its own internal resistance. So these are the drawbacks of these circuit elements. So these are the applications we have already discussed, but let us again revise it. It is used in potential dividers and current limiters and biasing circuits. Resistors are used in these. These are almost used in all the electronic devices. Capacitors are used for power supply smoothing, just like I have mentioned you the concept of filter. So timing applications it is also used. It is used in oscillators. It is used in power systems too. So it is also used in coupling and decoupling of signals. Again, the function is similar to that of a filter. So inductors are also used in transformers, in filters, and in energy storage devices. They are also applicable in radio frequency and inductive charging systems. So this is a brief overview of Ohm's law. Better, you already know what is Ohm's law. So here voltage is directly proportional to current under normal temperatures and conditions. Okay, and the final expression we get is V is equal to I. And you already know what are the abbreviations for V, I, and R. So this is the analogy of Ohm's law. this person is the volt which is forcing the current to pass through, and this is the resistance which is limiting the flow of current. So this is the analogy. So the next topic in your syllabus is nodal and mesh analysis. Your topic of the syllabus is nodal and mesh analysis. So for these analysis we use Kirchhoff's law. We use Kirchhoff's laws. So what are Kirchhoff's laws? Let us study these in detail. So basically there are two laws. Kirchhoff's laws are divided into two parts. The first one is used for nodal analysis. The second one is used for mesh analysis. So let us start with nodal analysis. In your electronics industry, there are certain circuits which are having huge number of branches, branches. So consider this circuit. So let us say there is a voltage VDC which is applied in this particular circuit, and these are all resistances R1, R2, R3, R4, R5, R6, R7. Let us say these are the resistances. Now it is obvious that whenever we connect this voltage to this circuit, there will be flow of current within this circuit. What will happen? A current will flow within this circuit. Let us say this is resistor 8. Now, what will happen? At certain points, let us say current has started moving from positive to negative. So at certain points, current will divide, and at certain points, current will recombine. Let us take an example. Let us say the current I has moved. Are you getting this yellow color on the screen, or it is Yes, not sir. Visible? Let us take red instead of. Okay, so let us say this is the total current I which has started from this battery VDC. It will divide like this. I1 component will come into this, I2 will come into this. This I2 will again divide at this place, let us say I3 and I4. This I1 will be divided into two parts, let us say I1 dash. Again I4 and I1 dash will combine to form the current I5. From here I5 and I3 will combine again to contribute towards I4. So at some points current is being divided, and at some points the current is being recombined. Let us consider the node A. These dots that I am making, these are known as nodes. What we call this? These are known as nodes. Nodes means where certain elements are joined together. These points are known as nodes. Now, the current sometimes recombines at nodes, and sometimes it splits from these nodes. Now just take the example of node A. This is node A. Just take the example of this. Now I2 is being divided into which parts? It is being divided into two parts, I3 and I4. But it is also observing some opposition of current. Let us say this is I5 dash. So these two are recombining, and this is opposing this flow of current. So I mean to say that if I take only node number A, so there are four branches associated with this. this is, let us say, I3, this is I2, this is I4, and this is I5 dash. Can you relate this particular figure with this node number A? Can you relate this? Yes, sir. Okay. Now, what is happening? Two currents are approaching the node number A and two currents are leaving the node number A. So what Kirchhoff's current law? It is known as KCL, Kirchhoff's current law. Kirchhoff's current law. What it states? It states that sum of approaching currents at a node is equal to sum of leaving currents at a node. You understand what I am saying? The number of currents or current elements which are approaching a node, their sum, and the number of currents which are leaving the node, their sum will be equal to each other at a particular node. For example, in this case, I2 plus I5 dash will be is equal to I3 plus I4. Is that clear? I hope this is clear to you. Just take 2 minutes to revise this and let me know if there is any doubt. Any doubt, better? No, sir. Okay. Now let us start with the formal definition of Kirchhoff's law. So it is used for analysis of complex circuits such as bridge or T networks. Only Ohm's law cannot be implemented in such circuits, in such complex circuits, so we need other laws, which are Kirchhoff's circuit law or Kirchhoff's law. These are of two types, Kirchhoff's current law and Kirchhoff's voltage law. The one we have done now is known as Kirchhoff's current law. Now this is the logic. Kirchhoff's current law is based on the principle of conservation of charge. It is based on law of conservation of charge. It requires that algebraic sum of charges within a system cannot change. Thus, total rate of change of charge, which is current itself, must add up equal to 0. So rate of change of charge is current and the algebraic sum of this total current is equal to 0. Now consider this diagram. I4 is approaching, I2 is approaching, and I1 is approaching. That means the sum of these I4 plus I2 plus I1 will be equal to the sum of currents which are leaving. Those currents are leaving I5 and I3. It will be equal to I5 plus I3. Now, if you take these to the left hand side, the expression will become I1 plus I2 minus I3 plus I4 minus I5, and it will be equal to 0. This is the Kirchhoff's law. Any doubt? No, sir. Okay. No, sir. Okay. So this is IA. For this particular example, it will be IA, which is approaching the circuit, minus IB, which is leaving the circuit, plus IC, which is again approaching, minus ID, which is again leaving, and minus IE, which is again leaving, and the sum is equal to 0. So the algebraic sum of currents entering and leaving a circuit or a node is always equal to 0. You can also consider this example too. Any doubt? Any doubt, students? No, okay. So no, your next few classes will also be online. I think you might have got the message due to the weather conditions in Punjab. I think the classes 2 or more days will be online. So we will do some numericals on Kirchhoff's current law and Kirchhoff's voltage law along with their theoretical conceptual knowledge. Okay. So till now, if you are having any doubt, you can let me know. I will put this recorded video lecture on the YouTube, and you can repeat itself the lecture for better understanding. Is that clear? Yes, sir. Okay, so that's all for today. In the next lecture, we will continue with the Kirchhoff's voltage law along with the numericals of both Kirchhoff's current law and Kirchhoff's voltage law. Okay, beta? That's all. Thank you, sir.